Alright, you guys, so what we're looking at today is we're going to still continue to look at square roots. So all of our indexes will still be 2. Okay, and so what I'm going to do is I'm going to show you how to first simplify now when there's some variables in the problem, and then also how to solve these square roots now. Okay, so let's start with the simplify part, and let's start with number 1. And so we have 400z to the 6th. So for the number part, you can treat it the same way we have. So maybe let's try going maybe 4 and 100. Okay, and then 4 can split into 2 and 2. 100 can split into 10 and 10. And yes, like always, we could keep going. But if we need 2 of a kind, so all the indexes, like I said in the beginning, are going to be 2. So let me just write all the 2's in there. Okay, and so since the indexes are going to be 2, you just need groups of 2, so no point in keeping trying to go and factor out the tens, since you already have a group of 2 tens there. Okay, so I circled a group of 2, so I can definitely take 1 2 out. I circled a group of tens, I can definitely take 1 10 out, and then for the numbers, there's nothing left in there, so that's all I'm going to do with that. Okay, so z to the 6th, the way that you handle these variables is basically whatever the exponent is, that's how many of the letter it's trying to say they have in here. So there's 6 z's in here. So I'm going to go 1, 2, 3, 4, 5, 6. So I have 6 z's. Okay, and then all you do here is you circle them. Okay, groups of 2, there's a group of 2, there's a group of 2, and there's a group of 2. So like always, for every group, let's take them out. So I have a z here, a z here, and a z there. And if you look at this, everything is circled. There's nothing left inside the radical. So everyone had a buddy to be able to leave the house. So all of these things, when I multiply them together, are going to end up being just on the outside of the radical, nothing left inside. So 2 times 10 is 20. Then I have z times z times z, which is z to the 3rd. So final answer for this is 20z to the 3rd. Okay? Let's look at number 2. Same ordeal here. So we have 162 right here. So maybe for 162, let's try maybe 81 and 2 maybe. Okay. And then 81 can split into 9 and 9. We'll just drop down this 2 just so that it looks pretty here. And so I have a group of 9s right here. Okay, and so I could take one group of 9 out. Okay, but I still have that 2 that's going to be in there, which sucks. So this 2 is going to have to stay inside the radical later on. For our y's, we have 12 of them this time. We have a lot. So we have 1, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And as you guys get better with this, you may not need to expand out all the y's like this, but just for the sake of learning today, just to give you a visual way of doing this. Okay, so index is 2, which means I need groups of 2s. So here's a group of 2 y's, another pair, one right here, one right there, and then there's my last one. So how many y's can I pull out from this? I have 1, 2, 3, 4, 5, and then all the way up from there, 6. Okay, so outside of the radical are all the things in pink. Those are all the things that had pairs. So I have a 9, and then I have 1, 2, 3, 4, 5, 6 y's. So I have 9y to the 6th. Okay, and then inside the radical, I still had that little 2 right here left over, remember? So final answer for this is going to end up being 9y to the 6th, radical 2. Okay, so let me box this for us so that we know. So that's how you would take care of the letters, just expand them out, and then match, if it's pairs, match the index and make those kinds of groups. Okay, For number 3, it looks a little weird. It looks like totally different from anything we've done so far. It almost looks like an equation, right? But since the directions are to simplify, we're not solving. And so if you see something like this inside of a radical, what I want you to do is to think of it as if you're going to have to factor. I know you guys don't like to factor, but we got to do it. Okay, so this, because of the way it looks like, it's going to end up being a box trick factor 1. Okay, and we're adding to get the middle number, so there's 10, there's 10, and if you add those, you get the middle number, so you're good to go. Signs are going to be plus and plus because they're the same. So what I have once I factor is going to look like this. Okay. So like we had established a little while ago here, remember our index was 2, so we need 2 of a kind. And looking inside the radical, we do have 2 of a kind. We have 2 of a kind of what? We have 2 of a kind of the n plus 10s, okay? So I have 2 n plus 10s, and I just circled everything that's in the radical, so there's nothing left that's going to be inside. And it's the same idea as what we've been doing. So because I circled a pair, that means I can take one of them out. So I can take definitely one n plus 10 out. And since both things were circled in there, there's nothing left in the radical. So final answer for this is n plus 10. Okay, so first step for this would be to factor. Next thing would be to circle pairs. Even if they're pairs that have variables in them, they're still a pair. And then whatever you could take it out. Whatever's left inside, leave it inside. Okay? Alright guys, so let's go ahead and let's go on to the second half of what I want to do today, which is the solving portion of it. And so here is our palette here for solving, okay? So for number 4, what you're trying to do is you're trying to get me an answer that looks like this. M equals something. M equals a number, okay? So we're trying to get this M by itself. So to do that, maybe the first step I would do is add 50 on both sides. Maybe divide 2. Okay, and then now we get to this point. So I want to know as a final answer what M is going to be. I don't care about what M squared is. I want to know what M is. So back when you were in junior high, they taught you how to solve things, okay? So what you might have remembered was that to plus and minus would end up being a good way to cancel each other out. Times and divide would be a good way to cancel out. Well, when we have this exponent thing, to get rid of an exponent, I'm going to put a little 2 up there. To get rid of an exponent, you square root both sides. So you just want to make sure that the indexes pretty much match. Okay, so we're going to square root the left side, square root the right side. And then what will happen is, because this index, remember when there's nothing written in the index, it's a 2. So because the index and the exponent match up, that means that they cancel out. So this is going to cancel, that cancels, the radical goes away, and you're just left with M. So the opposite of an exponent is putting a radical on it. Okay? And so then you go over to the right side, and the square root of 25, someone told you a long time ago that answer was going to end up being 5. Okay, I'm going to tell you that it's not only 5. So let's go back to this step right here. M squared equals 25 right up here. Okay, so you guys found 5. So 5, yes, if you square that, 5 squared equals 25, that's definitely true. But do you agree that this situation is also correct? Negative 5 squared also equals 25? That's true too, right? So there's actually, when you're solving these situations these problems that we're doing right now, there's actually going to be 2 answers for this. So it's not just going to be positive 5 that's going to be an answer. It's also going to be negative 5. So for all of these equations you're solving, and you're going to have to draw in your radical to cancel out the exponent, 2 answers, positive 5 and negative 5. We call this symbol plus minus, so it's a plus minus 5 for this one. Okay, so always 2 answers, don't forget. That's one of the number 1 things people forget when we get to this lesson. Okay, let's look at 5. So we're trying to get this R by itself, so we're going to add 500, add 500. Okay, so we're right there. This is canceled, so we have 45 r squared equals 500. We're going to divide both sides by 45. And we end up with that, which is a super big number, but it could be reduced, right? Maybe if we divide the top and bottom by 5, we could reduce it to something. So we could go 100 over 9. Okay, so just like what we did in the very first section of when we were learning these square roots, let's cancel out that exponent first. So remember to cancel it out. We radical both sides. Okay, and match the index up, so 2 and 2. Okay, so on the next line, it's just going to be plain r now. And then when we square root a, or when we radical a fraction, you're radicaling the top. So it's really, you're really saying that we have the square root of 100 and then the square root of 9. Okay, so what is the square root of 100? It's 10. Square root of 9 is 3. And then remember, because we're doing these radicals here, what do you have to always put in front here? It's not just positive 10 over 3, but it's also negative. So final answer for this is going to be plus minus 10 over 3. And that's it. So just don't forget, you guys, the two weird things. I think the really weird things we did was the plus minus thing when we solve. And then also the when we factor, when we're simplifying, that might have been a little weird, so maybe rewind it and rewatch it and see again. Okay, so that's it, and don't forget to take the quiz.